Hey guys, we're going to be talking about changes in matter and exploring the states with the PhET simulation. But before we do that, we're going to review and go over different states of matter. Matter makes up everything in the universe, and matter can be a solid, it could be a liquid, or it could be a gas. So those are the three forms. When we think of a solid is that state of matter with a definite volume and shape. So when I think of something that is solid, if I were to pick up a bar of soap, it definitely takes the shape of the soap bar. It definitely has volume and it takes up space. Or if I was thinking of an ice cube is a solid. It has the shape of its own cube and it definitely takes up space. Where a liquid, it also takes up space, but it doesn't have its own shape. So if I poured water in a round bowl, it's going to take the shape of a round bowl. If I were to put water in a cube, it's going to take the shape of a cube. And gas is a lot different than liquids and solids because it doesn't have its own shape and it doesn't have its own volume. So if I were to blow air, which is a gas, into a balloon, it's going to take the shape of the balloon and it's going to fill up all the space that's available in the balloon. Now, if you take that balloon and squish it, it's going to take the shape of that balloon squish shape. So the three states of matter, you have a solid, a liquid, and a gas. Those are the three states. But how can they change from one state of matter to the next? So we're going to look at that by looking at a PhET simulation, which is a really cool simulator. And I'm going to go through each of the steps with you. Hi guys. So the first thing that you're going to do is you're going to go to Google Classroom. And on Google Classroom, what you're going to do is you're going to scroll down to where it says PhET Simulator. You're going to go down to that and then you're going to click on this simulation and it's going to bring up this screen. When you do that, what you'll do is you'll click on the little arrow that looks like it says play. It takes a moment for it to load up, but once it loads up, you'll see this logo on there and it says PhET Interactive Solutions. Once it does that, you're going to click on this box that says States. And it's going to bring up this screen. The first thing you're going to do when you get on the screen, you're going to look for this little thermometer right here. Okay? This thermometer is going to be a big deal for you. So if you were to look right here, that's the thermometer that you're going to need. Okay? So then what you're going to do is you're going to click on that box and you're going to click down to where it says Celsius. Kelvin is a measurement of temperature, but Celsius is what we're used to using in science. The next thing that I want you to do is you're going to go ahead and you're going to take your mouse and I want you to go all the way down over here and I want you to click on the water molecule. All right, so you'll go ahead and click on that water molecule and then you will then what you do, you'll click on that water molecule and then you're going to click on solid. Okay, once you click on solid, you will see that we have a bunch of water molecules here that kind of look like Mickey Mouse symbols. The reason why they do that is because the red part represents oxygen and the little white parts represent hydrogen. But we're just going to pretend that they're circles right now. One of the things you're going to do next is we wanted to see what it would look like if we were going to add some heat. All right, so the first thing that I want to do is I want to kind of look at this and see what exactly are the particles doing. And then I'm going to draw it in box number 1, the first box on our PhET simulator, changes in state, and make sure we have everything written down on that sheet. We're going to write down our observations and even the temperature. So go ahead and do that right now. This is the spot right here where we're going to draw what we see exactly on the screen. You're going to draw using the, particles that are in the middle of our simulation. We're going to describe the temperature, and we're going to describe how fast the particles are moving, how close they are to each other, and if there's anything else that you want to add. The next thing that we're going to do is we're going to focus on the heat, okay? So it says on your sheet for box number 4 at the bottom of our sheet, it says to add heat to our system by adjusting the heat at the bottom of the simulator. As the heat increases, what we're going to do is we're going to try and write down some of our observations. Okay, so what I'm going to do is I'm going to click on that little bucket on the bottom, and I'm going to add some heat. As it's doing that, you can look at the temperature in the thermometer to see that the temperature is going up. I'm going to take it up to 100 degrees Celsius. Oops, go down just a little bit. All right, so right now it's at 100 degrees Celsius. What I want you to do with this is I would like for you to use the observation words, and I want you to draw a picture of what you see and describe with those observation words in box number 4. Go ahead and do that right now. The next thing that I want you to do is you're going to go to 500 degrees Fahrenheit. Again, we're going to be looking at that temperature range, and we're going to be adding heat until it's 500 degrees Fahrenheit. I'm sorry, Celsius. So we're going to go up in temperature. Watch what's happening to each of those molecules as we're going up in temperature. It keeps going and going, and those molecules are doing some pretty wild things right now. Oops, we went way above 500. Just add a little coolness. There we go. Now what I want you to do is in box number 5, I want you to draw what you see, and then I want you to use those observation words to describe what's happening inside that canister. Go ahead and do that right now. The next thing that I want you to do for box number 6 is I want you to reduce the heat again. So this time what you'll do is you're going to pull the little lever here. You're going to pull it down to where it says cool, and little ice cubes are going to appear. I want you to move it down to 200 degrees. So we're going to move this back down to 200 degrees Celsius. When we move it back down to 200 degrees Celsius, we're going to record what we see in our observations. We're going to draw that out, and we're going to use those observation words, okay? So in box number 6 right here, we are going to draw our picture of what we see in the screen, and then I'm going to have you write down some of those words, those observation words. Go ahead and do that right now. For the last part, what we're going to do is we're going to move this lever again. We're going to move it until this temperature drops all the way down to the lowest it can go. So it's dropping and our molecules are moving, but they're starting to do something. What are they doing? We keep going lower and lower and lower and lower and lower. eventually the thermometer stops. Okay, so as low as it can go. And do we notice, is there any movement happening to those molecules? Is there anything that's causing them to go close together or far apart? So what we're going to do in box number 7 here is we are going to add in our drawings and of what we see, and then we're going to use those observation words again in order to tell what we see is happening. So we're going to do that right now on our sheet. So in our boxes, we have some things that we should have written. When we looked at the solid that we clicked on water at the first time for box number 3, we should have seen that the atoms or the molecules are very attracted to one another. We should have also seen that the movement, they were vibrating in place, but they weren't moving past each other very freely. And the volume of the shape, it didn't have a definite volume and a definite shape. So it did have that shape and it did have that volume. In liquids, that would have been box number 4 and box number 6. When we had our liquids, we noticed that the atoms or the molecules are attracted to one another. They were vibrating and they were able to move freely about the canister, and they were able to bounce into the walls. They have a definite volume. They took the shape of the bottom of the canister, but it also took the shape of the air above it. It did not have a definite shape. Now, gases, we have atoms or molecules that are barely attracted to one another. All right, they bounce off and away from each other. They vibrate and move very, very freely past each other. And they don't have a definite volume or shape. And so it expands for the whole canister. So on the top of your next page, there's a question and it says, how fast or slow particles are moving? And that is called kinetic energy. So go ahead and fill that in right here. Kinetic energy is that word. In the simulation, which particles had the most kinetic energy? Would it be the gas? Would it be the liquid? Or would it be the solid? Go ahead and answer your question number 2. Look at the pictures on the bottom of the screen in order to determine which one you felt had the most kinetic energy. Last but not least, which particles had the least amount of kinetic energy? We're going to answer that question for question number 3. You're going to choose either a gas, a solid, or a liquid. Go ahead and write your answer in right now. The last question that you need to answer is right here, question number 4. So it says on here, particles in liquids move around freely and at different speeds. Faster moving particles have more kinetic energy, and slower moving particles have less kinetic energy. What about gases? Do the particles in a gas move around like particles in a liquid? What do you think? I want you to write your answer right here for number 4. We're going to do the rest of this when I get back to school on Monday. So great job, guys. I'm proud of all the work that you did. Keep it up, and I'll see you on Monday.